All right, class. I assigned Chapter 9, Question 7 as a follow-up problem from Unit A, and I have come up with a dummy problem here that's a little more complicated than that one, that follows all the logic you're going to need to use in order to solve that problem. It is a make or buy question, which is super common in the manufacturing world and business world. If you are a manufacturer, how much of the things that you make should you make for yourself versus how many of those things should you purchase from another vendor depending on their price and availability. So imagine a cola company that makes a regular cola, a diet cola, and a cola zero. The demand for those has increased to 10 million cases, 15 million cases, and 20 million cases respectively. The company's production process involves 4 processes: batching, filling, packaging, and shipping. And we have a certain number of available monthly hours and a number of hours of consumption for each type of manufacturer, along with the variable cost per unit and the retail price per unit. There's a co-packer out there that will do this work for you for the price of $10,250 per 1,000 cases delivered. And that, that comes out to be that very, very typical $10.25 per 24 pack that you're accustomed to seeing on the shelf when it's on deep discount. So I'm going to go ahead and start expanding our data table to include those purchased items. So I'm going to put that across the cost. Okay. The retail price is going to match the other retail prices. And then it's the idea that for each one of these colas, etc., we have the buy cola, the buy diet, and the buy zero options. Okay. In order to get to a solution here, we've got to then start identifying what are our constraints and what are we going to have as our decision variables. So our decision variables are how much of each one of these are we going to choose to produce. And we already know we have a series of constraints and options that are here. So I'm going to come down here. I'm going to drop those constraints in here. There we go. I'm going to put dummy values in my decision variable locations so that I can know if my formulas are doing something. And I know that my batching here, based on how many units I produce, I'm going to have to tally up how much total time I've. Okay, so for each process, I'm going to use my sum product. And it's the sum of my demands on that process times my sum of my choice to manufacture. There we go. And if I'll come in here, I don't want this array to copy downward, but I don't mind the other one doing that. Including my variable cost and my retail price. Okay. Go ahead and reformat these two. Okay. That's my total costs. Okay. I also need to know what was the sum of what I purchased. Okay, because there's a limit there in terms of how much total I can get in the marketplace. I also need to know, I'm going to borrow some formatting from up here. I need to know how much total cola I made, total diet I made, and total zero that I made. So those totals are the combination of the made cola and the bought cola, the made diet and the bought diet. And I know what my targets were in each of these cases from the text above. And while I in the text it talks in terms of millions of cases, we're going to do this in thousands of cases for representing the numbers here. Okay, so I think we've got all of our constraints built in. So we're going to go ahead and open Solver. And I'm going to reset all because I've been playing with this model a little bit. And I didn't build in. So I've got to put my profit term in here. Okay, and my profit is my retail price minus my variable cost. There we go. Okay, now I'm going to go back into Solver. Select that cell I just created. I'm going to maximize that by changing all of these cells. And I've got multiple constraints here. So I know that my total consumed batching time must be less than or equal to my available batching time. And I can actually do this faster. I'm going to go ahead and do it with the arrays. I'm going to take that first one out. Okay. I'm going to add the constraints. So I know that my batching, filling, packaging, and shipping times must be less than or equal to my available batching, filling, packaging, and shipping times. I'm going to add a constraint that I know I need the amount of stuff that I produced or have available to sell must be greater than or equal to my stated demand. I know that some of my purchases must be less than or equal to. I'm going to click this cell. I forgot to put that scalar in there. I like to put them in the sheet. Go ahead and click OK. I'm going to close this for a moment. I'll fix that oversight on my part. So I've got up to 25 million cases available for purchase. Go back into Solver. Add a couple more constraints. I'm going to say that all of these must be non-negative, so it must be greater than 0. Click OK. All right, so I've got my production constraints, my production minimums, the maximum of what I can purchase. Let's see if it will solve. It did solve for me. And it's always interesting in some of these, and I did build this one intentionally to do this, to show that some of the products that I normally would make for myself, it's more profitable for me to go ahead and purchase those. Now in this case, I ran completely out of batching time, so I could not have produced any more if I wanted to, but I prioritized producing the items that were the most profitable in my situation, and then purchasing the items that made the most sense to purchase from the outside. And having a soft drink division that's got 71 million in profit out of our previously stated 45 million cases in production. That's a little better than we see in the real world, but it's not completely out of spectrum. So there's an example of a make or buy.